I'm going to prove this theorem, which is really one direction of a theorem in the textbook, that suppose you have a function on AB, it's bounded. If f is integral on AC and CB, then f is integral on AB, and the integral equals exactly what you learned in calculus. Okay, so the proof. So first, I'm going to prove that f is integrable on AB. And then I'm going to show that this equation holds. And I'm going to use my favorite theorem a couple different times. And that is, I'm going to suppose that, well, how about let's just do it. Let epsilon be bigger than 0. I'm going to prove that f is integrable, that I'm going to do u of f of p for some p minus L of f of p is less than epsilon. So f is integrable on AB. This is the structure, right? This is the theorem. If I can show that this is true, if I can find a partition P such that this is true, then I will be set. But I'm going to use the fact that since f is integrable on AC, there exists a P1 such that u f P1, by the way, P1 is a partition for AC, minus L of f P1 is going to be less than epsilon over 2. Similarly, there exists a P2, a partition P2 of CB such that u of f of P2 minus L of f of P2 is less than epsilon over 2. So what am I doing? Just kind of over here with the scratch work. If I have here A, B, and here's a point C, well, P1 means I just have a partition. Maybe it looks like that there. And P2 says I have a partition maybe just like that. And I'm going to do the next natural thing. I'm going to let P equal P1 union P2 be a partition of AB. That actually isn't written out that well. I'm going to let P equal that, and I'm going to note that it is a partition of P2. I'm not defining it to be, it just is. So between A and B, take the red marks and the blue marks together, that's a partition. And then what I have, then this is going to be a little crunched, u of fp minus L of fp equals u of P1 union P2 with an F in there, sorry, minus L of F P1 union P2. Well, we discussed this. This was a clicker question, that if you have a union of two disjoint sets, then you just kind of distribute over this. You have u of F of P1 plus u of F of P2 minus L of F of P1 plus L of F of P2. But then let's stop fooling around here. Notice what I have here is I have u of f of P1 minus L of f of P1, which I know is less than epsilon over 2. I also have u of f of P2 minus L of f of P2, which is less than epsilon over 2. So what I get is that for this particular partition, UFP minus LFP is less than epsilon. So I can conclude that f is integrable on AB. That concludes the integrable part. I'm going to, in the next podcast or screencast, prove that this equation is true. That the integral of f really is equal to the integral of f plus the integral of f with the appropriate limits of integration.